Hello everyone, I'll be going over what we need for Lab 1. So to begin, to recap, we have several different parts of RStudio. We're going to be using RStudio, not R. So the first part, we have to install we have to import our data set, which we're going to do over here from environment. Before you do that, you might want to get a new file started. So you can just click on New File and do R script, and that will pop this up. You can rename that if you wanted to. It's not letting me rename it at the moment. Forgetting what to do, but there's a way to rename it. You could call it like Lab1 if you wanted to. We'll be working off of this data set here. So this area is called the console, and you'll see these little hashtags. If you put a hashtag at the beginning of a line, it will turn the text green, and that means that these are just like notes. These are just telling you information. And it's not going to run programming. So you see here with Lab 1, if I hit run, it doesn't do anything down here except display the text. But if I go here, I said this text was black before I highlighted it. I hit run. It did do something. You just can't see what it did yet. But anyway, so for the majority of things that we have to do, we have to start with a data set. So we import data set. In this case, it's from Excel. You go, you click Browse. Should be in your downloads. In this case, I want the original one. You can see I've downloaded it a couple different times. You'll see, even though these are all the same data set, the name will be slightly different when it's imported, so I want the original one. So yes, I want the original data file, downloads, lab1_students. That's what we downloaded. You see all of this information populates. We don't need to worry about any of that. If you wanted to name it something simpler, say Lab 1, you could edit it here. So in this case, I'm going to switch everything over. I'm going to just call this Lab 1, and that'll make some of my commands a little bit more simple. So I've imported the data set. Now what we need to do, and you'll see that this information here matches this information here, right? So in these particular instructions, it had us go ahead and install QDAP. So we could do, I guess we do actually need to do that in order to get the distribution. So we're going to, in our console, install packages, parentheses, QDAP. You'll see I hit run, pops up some red text, and it's run. You don't necessarily have to highlight the whole thing. You can just click at the end of the line and click run. It will do the same thing. So we've installed the package. Now we want to tell it to reference the package, and we use that with the library command. Library QDAP. And you see it has loaded that package. So we're going to use dist _ tab parentheses. In this case, I renamed my lab So it's going to be just Lab1, and then the $sign is how you tell it what column to reference. So what we're looking at is quiz 2. And so by putting that $sign and then quiz 2, it's telling it to reference that. So we click run, and there is our frequency distribution table. So you'll do that for quizzes 2, 3, and 4. Next, it says we're going to make a bar graph. Right? So question 2, you're just going to use what you have. If you want to use additional tools, you can. If you want to calculate it by hand, you can. Question 2 is about reinforcing your learning in the lab. Question 3 instructs you to make a bar graph. So let's just go ahead. We'll make sure that we're still running off of library, QDAP. Should be, but we're just going to tell it to do that again. Now, we're going to use this tab again, but this time we want it to reference the grade column, right? So it's $grade instead of quiz 2, quiz 3, or quiz 4. So let's go ahead and hit run. You can see a frequency distribution table comes up. So now we're going to do a different command, which is we're going to assign a variable, right? We're going to define an object. So we're going to, in this example, it uses grade.frequency, F-R-E-Q. So what you can do is space and then equal space, and then you're going to say what type of thing it is. So it might be a count, it might be a table, it might be a matrix. You'll have to define what that is. For this one, we need a table, right? So Lab1 $grade to assign grade frequency equal to the table, right? So a couple alternatives to make it more clear so that you understand. If I wanted to, I could just call this thing. And I can say equal to table underscore lab1. I can click that to make sure I have the right one. Oops. $grade. Now, thing and grade are both objects that contain the table that it pulled right from the grade column on this spreadsheet, right? This column over here with their letter grades entered. Alternatively, if you have a thing against equal signs or it's confusing to you, we could also define it as, or by doing a little pointy arrow with the less than sign and then a regular dash, and do table This is just to show that you have options, right? So now we are going to get the bar plot, you use the bar plot command, right? And we just defined our object as grade.frequency, and there it is. Right click this, copy image, and paste it into your document. Okay. Now, for the second part, we're using a data set that is entered directly into your Word document. Just go into your Word document and copy all of the numbers. Now, what we want to do is define some object as that set of numbers. If it's just a set of numbers, it's a count, C. So we're going to use C. So you would just type C, parentheses, and hit paste. Oops. That was unintended. That's what happens when you don't hit copy first. Okay. There you go. Let me try that again. So we're going to take the numbers. You would take this directly from your Word document. Go here, hit copy, C. Make sure that those parentheses are on the front and the back ends. Right? And you can see it listed all of them out there. But we need to also define an object. In this case, they use Q. But you could name this anything. So you could call this Lab1 second part, for example. You can use the pointy arrow, or you can use the equal sign. And just for consistency's sake, I'll say C parentheses paste, just to show you it works exactly the same way. Hit run. Okay, so now let's see what happens when we do mean. If we want the mean, we just use the mean command. Lab1 second part. You see it pops up. That means it was successfully defined. So we're going to hit run, and there's our mean. Now, for the median, you would do the same thing, right? We already defined Q. Q works too, in this case, because I defined two objects with that same name. There we have Q, and we have lab second part. If you're wondering why we might use something longer, every time, if I were to use Q again in the future, that would replace it. So if you use a specific name that you're never going to use ever again for any reason, that information will always be stored in here as long as you don't delete or lose that data. So median, you just do median and then whatever you define the object as. For mode, we're going to need a new package. So we're going to do install.packages, quotation mark, mode, estimate, EST, in quotation mark. It works a little bit. It says it's successfully unpacked. Great. Now, there's the require command and there's the library command. I can't tell you exactly when you have to use one or the other. I can just tell you last semester I never used the require command. The library command always happened to work for me, but just in case, it might be important for you to know that if library isn't working, right? Like let's say this is dependent, okay. This command that we're going to use in a second is dependent on this package. If this package isn't active and working, this command will not work. So, require is a more forceful way than library to like make the system say, okay, it's on, right? So use require. You could also try library, but you may not even need to do that when it comes to exam time because you might already have it active and running. But in any case, to get the mode, we're going to use most frequent value, MFV, and then whatever we defined our object to be. You see it successfully and correctly says that 25 is the most common value. And you can eyeball it and see that that's the case. There's 4 25s and there's 3 24s. All right. For range, range will not do the subtraction in R, but you're just going to use R and you'll just print out this output. Keep in mind for class, you will have to do the math. But if it just asks for the R output, you can copy and paste what R says. Now the sum of squares here, this we have an example of typing out the whole formula, and this can be really helpful. You guys can see this is the formula for sum of squares that you learned in class, right? So you've got the total of all of the values in the sample minus the mean of all of the samples, right? And then you squared each of those individual values. That was a long and lengthy process, but by just typing in the formula in R and hitting run, you get the sum of squares calculated for you. For variance, it's not dependent upon a package. So you've got your variance, you've got your standard deviation, and that's that. Now, final thing that we're covering is if you need to transform data. If you're multiplying all of the values by 3, you can just do that by telling it to multiply the data set itself by 3, right? So the data set was Q times 3, and this is the little asterisk sign, right? So don't use the X, use the asterisk, and it tells you what the mean would be if you multiply by 3. Right. I would encourage you to take a second and see how does that mean compare to the other mean, right, that you ran the statistics for. And then compute the standard deviation. And voila. And this makes sense. It's 3 times more distributed because all of the numbers are 3 times more apart from one another, right? So that is what you should need to know. I'm going to take a quick look at the homework just to make sure that there's nothing else you need. Give me a second. Okay, something you need to know is it says paste the R syntax and the output to the Word file. So you have 2 ways of doing that. If you're using this up here, you can copy and paste whatever it is. So, for example, like, if you're using the script, if you wanted to, you could include the green text, whatever hashtag stuff you have. That would be fine. You can do that. If you copy and paste it from some Google source, some web source, you did it a different way, you'd installed some other package. The key thing would be to make sure that if it's dependent on another package, that you are including that down here or on your homework sheet. The other thing is, technically, your syntax and your output are both down here in the console, so you can copy and paste both. One thing to keep in mind with that is I always like click down here, make sure I've got the flashing bar down here, and then go and highlight and copy. It's really easy to accidentally have the cursor up here, go down here and hit copy, but you failed to copy. It doesn't actually work, and you'll just be annoyed when you hit paste in your Word document. So make sure you actually have the console clicked on and do this copy paste into your Word document. So this part is the R syntax, which is the same as up here. The R syntax, I'm referencing a different set, but R syntax, either is fine. The R output is this, right? And what I encourage is to just take it from down here. It's easier. Everything is combined. You got the R syntax and the R output together. Other things for the quiz or for the homework, you do have to do the line graph by hand. You can use R to calculate the percentage, or you can do it on your own. That is up to you. You just need to elaborate on what you did, like show your work. So if you used R, show that information. If you did it by hand, like, you know, show what you did, right? Another data set, mean, and you see in this example it says what is the mean for the sample. You can technically do that by hand, but you're going to take more time because you already have to use R for the sum of squares, the variance, and the standard deviation. Okay, and that's it. That should be all you need to know. I hope everybody has worked out the computer issues that they're having. Thank you so much, and take care. Good luck. Look forward to seeing your results soon.